You chose B. That is indeed the correct answer, and let's look at the reasoning. The fugacity is the driving force, and so what we're saying is the fugacity of pentane in system B is greater than the fugacity of pentane in system A. And if the fugacity is higher, then the amount absorbed is higher. And it does not matter whether zeolite is in the liquid or the vapor phase. If I had switched and put this zeolite in the liquid phase, the answer would not change. If I moved this zeolite to the vapor phase, the answer would not change. Why is the fugacity higher for pentane in B? Well, the easiest way to visualize this is to look at a PXY diagram and compare these two systems. So I'm showing a PXY diagram where I'm plotting pressure versus the mole fraction of pentane. Pentane has a higher saturation pressure. So system A, the vapor is 50%, so this is system A here. And then here, the liquid is 50%. And so we can look at these diagrams and say, for system B, the fugacity of pentane in the liquid phase is going to be equal to the mole fraction of pentane in the liquid phase times the saturation pressure of pentane. So this is 0.5 times the saturation pressure of pentane. For system A, we can say the same thing, that the fugacity of pentane in the liquid phase, and the hat is to symbolize that we're talking about a mixture, is the mole fraction of pentane for system A, the saturation pressure. The saturation pressure is the same because we're at the same temperature. This is not necessarily the exact diagram for pentane-heptane mixture, but the behavior is the same. And so we can see the mole fraction is less than 0.2, let's say 0.17. So fugacity pentane liquid phase for system A, 0.17 times the saturation pressure. Well, clearly this number is much higher. This has the higher pentane fugacity, and therefore it has more pentane absorbed in the zeolite, independent of whether I put the zeolite in the liquid or the vapor phase.